Welcome to the Owens Valley Radio Observatory. My name is Dr. Mark Hodges, and I've worked here for 37 years, and I'd like to take you on a virtual tour of our observatory. What we do here is astronomy at radio wavelengths. It's similar to optical astronomy, but instead of observing on mountaintops when it's dark, we can observe right here on the valley floor 24 hours a day. The observatory was started in the 1950s, and this site was chosen primarily because of its isolation and because it's flat. The Owens Valley lies between two mountain ranges, the Sierra Nevada Mountains on the west and the White Inyo Range on the east. We have some exciting projects going on, and I'd like to tell you about them. Let's start with this telescope. This telescope is called the 40-meter telescope because it's about 40 meters in diameter. It's the second largest dish in the United States and one of the oldest telescopes at the observatory. The radio waves travel through space, bounce off the dish, and are collected at the focus, where we put a receiver, which converts the radio signals into electrical signals. Currently, the 40-meter is observing over 5,000 radio sources, most of which are active galaxies. Let's go up to the catwalk, where we can get a nice view of some of the other telescopes. Here we are about 55 feet above the valley floor. To the north, you can see several dishes. The 6 larger ones are called the 10-meter dishes and were built to be used at wavelengths as short as 1 millimeter. Currently, only 2 of these are in use, but we have plans for the other 4. One telescope is observing highly redshifted carbon monoxide gas from the early universe in a project called CO-MAP. The CO-MAP receiver has 19 feed horns, each of which are looking at separate patches of sky, all at the same time. Farther out to the north, you can see a white shelter, which is where the long wavelength array is located. We'll be going out there in a little bit, but you can see a bunch of smaller tan-colored dishes. I'll tell you more about them in a minute, but let's first go over to the CO-MAP antenna. We're now on the platform of the CO-MAP antenna. The signals from the receiver come down and go into electronics in the side cab, where they are digitized and analyzed by special computers. From here, we can see some of the 4.5-meter dishes used in the Deep Synoptic Array, which we call the DSA. Currently, we have 24 antennas, but we're building more to bring the total up to 110 antennas. The DSA was created to search for fast radio bursts, which are millisecond-long bursts of radio noise whose cause is still a mystery. These antennas are small, so they're sensitive to a large patch of sky. The signals from each antenna are correlated with the signals from all the other antennas, which increases the sensitivity and also enables us to create images to find out where these bursts are coming from. Next, we're going to travel out to the long wavelength array. This is the long wavelength array. Each of these antennas can pick up radio signals from the entire sky. The signals from each antenna are then sent into this shelter where, just like the DSA, the signals are correlated. We create images of the entire sky at the longest wavelengths that can reach the surface of the Earth. We currently have about 300 antennas, and very soon we'll be adding new antennas and computers which will increase the sensitivity and quality of the images. There's one last place I want to show you, and that is the dormitory at the west end of the site. When you come to work or observe at OVRO, you will likely be staying in our dormitory. We have 5 very quiet, peaceful rooms with great views. Make sure to pack your hiking shoes, as there are a lot of great trails in the mountains, or in the wintertime, make sure to bring your skis, as Mammoth Mountain is just an hour away. Thanks for watching, and we hope to see you soon.